Well, hello Internet, and welcome to part 2 of my tutorial on learning how to program by solving problems. In this tutorial, we're going to continue on where we left off from part 1. If you didn't watch part 1, definitely watch that. There's a link in the description, as well as a link to a cheat sheet, as well as a transcript of the entire video. And I have a lot to do, so let's get into it. Okay, so here I am back inside of PyCharm, and like I said before, every program is going to have the ability, or every programming language is going to have the ability to perform actions on a list of values. And the example I'm going to use here is the for loop. And how we create a for loop is we say for I in, and in this situation I'm going to provide a list of values that I want to cycle through. So just a bunch of even numbers, and we end that with a colon. Now each time we go through our loop, the variable I here is going to have a value from this list assigned to it. So the first time through it's going to get 2, then it's going to get 4, 6, 8, 10, and so forth and so on. And then what we're going to do is we're going to print out those values just so we can see how they are going to change. And that's all we need to do, and whenever we run it, you can see right here that it was assigned those values each time through the loop and printed those out. You can also use another tool called range to define the list for us. And if we would come in here and say range 10, then range will create a list starting at 0 and go up to, but not include the value that's passed to it. So it's not going to include 10 in this situation. And if we run that, you're going to see that it cycles through starting at 0 and prints out the whole way through 9. We're also going to be able to define the start and the end. So if, let's say, we wanted to cycle through here and print out 2 through 9, we could also do that, as you can see right there, 2 the whole way through 9. And before we get to our problem here, in which we're going to use a for loop, I wanted to also talk about how we can use modulus to see if a number is odd or even. Now, if we divide an even by 2, so let's say we do something like I with the modulus of 2, and then we go and check if the returned value, remember modulus returns the remainder of a division. If this comes back as 0, then in this situation then we know that this indeed is odd. So what we're going to do here is I'm going to assign I equal to 2, and then I'm going to print this out just to verify that indeed that modulus is going to tell us if we have an even or an odd number. So we can go and we can run it, and you can see the true comes back. So that is one way that we can check to see if a value is indeed either even or odd. And we're going to use that in our very first problem we're going to have here, in which I'm going to ask you to print odds from 1 to 20. And what you're going to want to do here is use a for loop as well as range. And then you're also going to use if and modulus to print out the odds. So you can either pause the video here, or I'm going to give you a couple tips on exactly what you're going to do each way through and then see if you get the right answer. So if you want to see some tips, what we're going to do here first is we're going to use a for loop that is going to cycle through the list from 1 to 21. That's the very first thing you're going to want to do. Then you're going to use modulus to check that the result is not equal to 0, and then after that you are going to just print the odds. Once again, you could pause the video and see if you can solve this problem on your own. I'm sure you can, and of course you could refer to the cheat sheets from previous parts of this video to solve this this little problem we have here. Okay, so hopefully you got this right. Now I'm going to show you exactly, at least my way of doing so. So we're going to use range again, and we want to cycle through the numbers 1 through 20. So we're going to use 21, just like I said previously, and go like this. And the next thing we're going to want to do is use modulus to check that the result is not equal to 0. And we need to indent. Remember, we want to use white space, and we want to do or perform these actions inside of our for loop. So what we're going to do is we're going to go if I modulus 2. And this time, instead of equals, we're going to say not equal to 0. Put our colon inside of there. And then whenever we come down here, we're going to indent once again because we're inside of the if statement. And we are going to print all of the values for I. And if we run that, you can see indeed that that does work. Cycle through 1, 3, da 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 da, and the whole way through 19. And that is how we would go and cycle through and print out all the odds. So hopefully you got that answer right. If not, don't worry about it. As you do more and more of these in practice, you will get better. Now I want to talk about working with floating point numbers. Now a floating point number is just a number with decimal values. And let's come in here and let's create one. So I'm going to say that I want to receive a value. So input, and we'll ask the user to enter a float. Then of course we want to convert this from the string into a float, and just like we used int previously, now we are going to use the float function to convert from a string into a floating point number. And now what we want to do is print out whatever value they gave to us, and what I want to do is round it to 2 decimal places. So rounded to 2 decimals. Once again, we're going to use our curly brackets, and then inside of here, if you want to round a value to 2 decimal places, you're going to put colon and then a period and then 2. And then since this is a floating point number, we're going to throw an F inside of there. And then once again, we're going to use format to define what value is going to be placed wherever the curly brackets are. And if we run that, it's going to say enter a float, and I could say something like 1.2345. And you can see right there, rounded to 2 decimal places, it's going to convert that to 0.23. Very important, and that is because now it's time for you to do another problem. And in this one, what we're going to do is demonstrate compounding interest. And what we're going to have to do in our program here is have the user enter their investment amount and their expected interest earned each year. Then what we're going to do is each year their investment will increase by their original investment plus their investment multiplied times whatever the interest rate is. Then, after that's all done, print out the earnings after a 10-year period. Okay? So you can go ahead there and try to figure out how to solve that problem, or I can give you a couple tips and then you can decide to go and do that. So what I'm going to do here is I'm going to ask for the money invested plus the interest rate, just like I said previously. Then I want to convert the value to a float, and then after I do that, I want to convert value to a float and round the percentage rate by 2 digits. That's a little bit of a trick that was in this problem, because if they enter in a 5 for 5%, well, to perform the multiplication, you're going to have to round that 2 digits. I'll show you how to do that. And then what you're going to do is cycle through 10 years using a for loop and range from 0 to 9. And then the final thing you're going to do, of course, is output the results. So you can go ahead and pause your video now and try to solve this. And otherwise, I'm going to show you exactly how this is going to work. So what we're going to do here is we get to this point, ask for the money invested and the interest rate. So I'm going to say money is equal to input, and I'm going to say how much to invest. And after we get that, I'm going to say interest rate is equal to input, and we're going to ask for the interest rate that they expect to earn. Now, of course, we're then going to have to convert the value to a float. So money is going to be equal to a float, and then we'll just pass money back inside of there. Then we'll come down here, and like I said, if they enter a 5, we want to convert that to 5%. So what we're going to do is we'll say interest rate is going to be equal to a float, and then I'm going to get the interest rate, and then I'm going to multiply that times 0.01, and that is going to round over 2 digits. Then I'm going to need to use a for loop to cycle through all these guys. So I'm going to say for I in range, and if there's any questions you have, leave them in the comment section below. I will answer every single question that I get. And then we're going to go money plus, and then we'll go money times whatever the interest rate is, And you can see as that goes on, money's value is going to continue to increase. And then finally what we'll do is we'll say print investment after 10 years. And we want to print that out, and we want to round it to 2 decimal places, colon 0.2f. That is how we define we want to put a floating point number inside of there with only 2 decimal places. And then the final amount of money they have. And we could save that, and we can run it, and we could say something like how much to invest, and we could say $10,000, and at what interest rate we could say 5, and you can see right there exactly how much money the person would have in their account after a 10-year period based off of a 5% interest, as well as an original investment of $10,000. So there is another problem. Hopefully you did well with that. Once again, if there's anything that's catching you or causing any problems, leave a comment below, and don't worry too much if you didn't get it right. Another thing that is very important is whenever we are working with floating point numbers, understand that floating point numbers in all programming languages are not necessarily precise. So let's say, for example, we define a variable called I, and we want to go and add up 0.1 and like this, and then subtract them. So you would think the value for I would be equal to 0, right? Well, let's go and see if that's true. There's I, and if we run it, you can see that it is a very small number, but that number is definitely not 0. And that is just based off of how floating point number calculations are done. But don't worry about exactly why it's that way. Just understand that floating point numbers are not necessarily precise. And just as another example, let's go in here and we'll throw some gigantic numbers inside of here. These are 32 digits long. And understand that floats will print nonsense beyond 16 digits of precision. So for the most part, whenever you're performing calculations on one float to another float, you can trust the first 16 digits, but thereafter, you're going to get pure nonsense. And here I'll show you exactly how that works. So we'll say answer, and then I'll just go colon. And here I'll say I want 32 decimal places of precision, and you're going to see that that doesn't make any sense in this situation, and we'll go I plus J, and we'll run it, and there you can see. If we look at this, you can see that all of these values in this calculation are correct, but after it gets past the point of 16 digits, the rest of this is all nonsense. So just be aware that whenever you're performing floating point calculations, that anything past 16 digits is going to be completely bogus and should not be relied upon at all. And another thing before we go on is I want to talk about order of operations. And basically, the way that works is that whenever we're making calculations, unless you use parentheses, multiplication and division are going to supersede addition and subtraction. So let's say we have 3 plus 4 times 5 and equal to, and throw this inside of here and go format and then perform that calculation. 3 plus 4 times 5. Understand that whenever we do this, that we're going to get completely different results if we would go and throw parentheses around these values just like this. And you can see indeed that this is the way it works out. Here what we're doing without the parentheses is multiplying 4 times 5 first, then adding 3, and here what we're doing is, because we have parentheses around this, is adding 3 plus 4 to get 7, and then multiplying that times 5 to get 35. So that is how order of operations work, as well as how floats work inside of Python and most programming languages, and some things that you should be aware of. And now I want to talk about another looping structure called the while loop. Now, we can also continue looping as long as a condition is true with a while loop. And while loops are used when you don't know how many times at the beginning you're going to need to loop. So what we're going to do here is we're going to use what's called a random module to generate random numbers. And to import a random module that comes with Python, we just go import random, and then we will be able to use all the different functions that are associated with this random module. Don't worry too much about import right now. I'll get into it later. Just understand that if we want to be able to calculate random numbers, that this library or module is needed to do so. We're then going to be able to generate a random integer between 1 and 50 just by going rand_num. Doesn't matter what this variable is called. I just chose rand_num. And then we will call random rand range. And if we want a random integer between 1 and 50, we pass in 1 and 51. And that will return a random value between 1 and 50 for us. Now, whenever we want to work with a while loop, the value we are going to be incrementing in the while loop is going to be defined before the loop. So that's what we're doing with I right there. And then what we're going to do is we're going to define the condition that while true we will continue looping. So we're going to say while I is not equal to the random number that was generated for us, make sure you spell this right, we are going to continue looping as long as this guy right here comes back as true. So now we can go and increment I, because you must increment your iterator while inside of your while loop. And we can use our little shortcut here, that guy right there, which is exactly the same as if we would type in I is equal to I plus 1. Just a shortcut, and I'm going to use that guy. So it's going to cycle through until it actually finds the random value, and then at that point we're going to say that we found it, and we're going to print on the screen that the random value is, and then print out random num. And if we run this, you're going to see the random value is 5. Run it again. Random value is 30. Run it again. Random value is 40, and so forth and so on. Now, before I ask you to do another problem, I want to talk about break and continue. Now, continue is going to stop executing the code that remains in the loop and jump back to the top of the loop, while break is going to jump completely out of a loop. So let's use an example here to show you exactly how those work. Let's say that I want to continue cycling through values as long as I is less than or equal to 20. Then what I want to do is if a number is even, I do not want to print it. So one way that I could do that is I can go back to our modulus example, modulus 2, and say equal to 0. Remember, we're going to have to increment our iterator each time through. So I'm going to go I plus equal to 1 to increment that by 1, and then call continue. So what it's going to do is if this condition is true, then it's going to come down and increment the value of our value for I to 1, and it's going to continue, which means it's going to skip everything that comes down here in the rest of our while loop and jump back up here and continue executing from the beginning of our loop. You're going to see exactly how that works here in a second. I can also come in and use break to jump completely out of the loop. So let's say if I is ever equal to 15, I want to stop looping altogether and quit the program. Well, I would just type in break, and that's exactly what that does. I still want to print some values, however. I want to print our odd values out on this screen. And if both those conditions come back as false, we're going to get down here and we're going to know we have an odd value. And then what I can do is just print that value out on our screen. And remember, however, we always are going to have to increment the value of I, and if it doesn't get here to increment, then we're going to have to come down here and increment it right there. And we could save that and run it, and you can see indeed right there that we were able to print out all those odd values. All the even values were skipped because of continue, and the value of 15 was never reached, even though we said we wanted to continue looping until this was equal to 20. And the reason why is right here when it says is I equal to 15 break, and whenever break was hit, that means we're going to jump completely out of the loop and run code under here, or if no code exists, of course we're not going to run anything. So there's an example of break as well as continue. And now comes your biggest problem of this whole tutorial. What I want you to do is draw a pine tree on the screen. So what you're going to do, this is going to be sample output, for example. You're going to say how tall is the tree, and they are going to tell you how many rows they want in their tree. And then what your program is going to do is print out a tree exactly like that. It's going to be able to work with any number of rows and be able to print any different height of pine tree humanly possible. So just to help you along in this, basically you're going to have to use 1 while loop and 3 for loops. Now, of course, there's multiple different ways to do this. This is just a guide, and the ultimate goal is to just do this. So if you think you can do that on your own without any tips, then go do it and see if you were right. And otherwise, I'm going to give you a couple different tips. But what I would like to do here is first break this down, and let's look at exactly what we're trying to solve. So what we have to do here is look at exactly what's going on. In our first row, let's go 1, 2, 3, 4. So what we know is in our first row that we are going to have to put 4 spaces followed by 1 hash symbol. And let's just analyze that. So we'll say 4 spaces and 1 hash. And the second time through, we're going to go 1, 2, 3. So we're going to have 3 spaces and 3 hashes. And we're going to see here that a pattern is going to develop. Right here we can go 1, 2, and we're going to have 2 spaces followed by 5 hashes. And if we continue indefinitely, this is going to be 1 space followed by, and this is going to be 7 hashes. And then finally, we're going to have 0 spaces followed by 9 hashes. Also, by analyzing this, we're going to know that this, whatever the top of our pine tree is going to be equivalent to wherever our stump is. So whenever we come in here to first print this first row, we should save this information so that we could also use it at the very end to get all those done. Okay, so now that we saw that, let's go through and try to figure out how we can solve this problem. So basically what we are going to need to do, is 1, we are going to have to decrement spaces by 1 each time through the loop. We know that's one thing that we're going to have to do with our program. We're also going to have to increment the hashes by 2 each time through the loop. Number 3, we're going to have to save spaces to the stump by calculating tree height minus 1. What else are we going to have to do? And this is how I break down programs. We want to go through here and figure out all the different things we're going to have to do in each state. We're also going to decrement from tree height until it equals 0. And 5, we're going to have to print spaces and then hashes for each row. And the final thing that jumps out at me here is print stump spaces and then 1 hash. So for no matter how many rows they say they want in their tree, this is going to be the rules that we're going to follow right here, and this is what we're going to have to implement inside of our program. So now you can stop right there and try to implement this. So there we go, multi-line comment and another multi-line comment. And now I'll go through exactly step by step what's going on or what I want to do inside of my program. So the very first thing that I want to do whenever we start off is to get the number of rows for the tree. That is the very first thing we have to do, the first line of code. Then, of course, convert into an integer. And then the next row is get the starting spaces for the top of the tree. We should also track the number of hashes the first time through, and we always know we're going to start off with 1 hash. So let's just say there is 1 hash to start. That will be incremented. We want to, as I said before, save stump spaces till later, because whatever we start off with in regards to spaces here on this row is going to be exactly the same as that. So at least I decided that I think we should save that for later to save ourselves some time. We then also want to make sure the right number of rows are printed. And I'll give you a tip, that's where the while loop is going to come into place. We are then going to print the spaces. And I'll give you a tip here because you don't know this. If you use end is equal to like that inside of print, that means a new line is not going to show up. And I'll show you an example of what that looks like. It's going to be print, and then we're going to put, whatever we have inside of there, and then we'll put end is equal to this guy right here. And whenever we use print with end like that, that is not going to force a new line, and that is going to provide us with the ability to print out the spaces without new lines as well as the hashes without new lines. So that's very important. and I'll just come in here and give you that answer right there. No problem. Then we're going to have to print the hashes, and we're going to use a very similar format to what we use to print our spaces. Then we are going to need a new line after these trees, right here, after each row in our tree. So we're going to want to call for a regular print that is going to have a new line after each row is printed. We know from our research that we did before that spaces is decremented by 1 each time through our loop. And you can see indeed, if we come up here, you can see the space is decremented by 1, as well as hashes is going to be incremented by 2. So we want to implement both of those, and we'll just say that hashes is incremented by 2 each time, and then also decrement tree height each time to jump out of the loop, because we need a way to get out of our loop. And then the final thing we're going to do is print the spaces before the stump and then the final hash, and exactly how we're going to do that. So that is the goal of our program, and step by step how we are going to solve it. So let's get up here and let's start writing our code. And of course, using all the tools we learned about, you should pause the video and try to do this on your own. Otherwise, you can see exactly how I'm going to do it. So what I'm going to do is I'm going to get the tree height that the user wants me to use in regards to printing out this pine tree. So I'm going to say, how tall is the tree? I'm going to get that, and then I'm going to go tree height is equal to, let's convert it into an integer. I then want to calculate spaces based off of the research that I did, and spaces starts out at whatever the tree height is minus 1, so I want to store that inside of there. I also want to calculate hashes, and I know that every single time I make a tree that hashes is always going to start out at 1. Once again, I'm referring to this right here, just the little bit of research that we did. I also know that I want to save the number of spaces before the stump, because that's going to be equivalent to the very, very top of the tree. So I'm going to go stump spaces is equal to tree height minus 1, just like we did here. I could also put spaces inside of there, doesn't really matter. And then I want to use a while loop here to cycle through and make sure that we get out of the loop someday. So while tree height is not equal to 0, I want to continue looping through this. Then I need to print the number of spaces that we want to use. So I'm going to come down here. I'm going to use white space, of course. I'm going to have to tab in, and I'm going to use a for loop here. So I'm going to say for I in range, and I want to print out the number of spaces that we're going to need here to do this the right way, and then tab that in, and that's going to print out our spaces. Then we're going to print out our hashes. This is going to be exactly the same as what we did up here for spaces. So let's throw that in there. Make sure that we have the white space all set up here right. And then this is going to be hashes instead of spaces. And of course, this is going to be a hash symbol instead of a space. Then new line after all of the hashes and spaces are going to be printed on the screen. And that's going to be right here, still inside of the while loop. And we can just call print on its own. That's going to print out a new line for us. And then also inside of our while loop, we are going to have to decrement each time through the number of spaces by 1. And we're going to have to increment the hashes by 2 each time we go through there. And then finally, we're going to have to be able to get out of our for loop altogether by going tree height is equal to, well, let's decrement that also by 1. And then after we get all of that done, after we've printed all that stuff out, down here inside or outside of our while loop, we want to print the spaces before the stump and then the hash symbol. So we're going to say for I in range, and we're going to throw stump spaces inside of there like this, and then we're going to say print, and we're going to throw in a space, and then we're going to end this with end is equal to and nothing. And then to end our program altogether, we're going to print out our stump and be done with it. So let's save that inside of there. As long as I don't have any silly errors anywhere, this should work perfectly. So let's run it. How tall is the tree? And let's say that it is 5 rows tall, and you can see that it printed it out there. Don't like the fact that I went and forgot to put that inside of there. Again, a space for my input. How tall is the tree? Shave it like that, and let's run it again. How tall is the tree? And we can make it 6. And you can see that it worked again. And how tall is the tree? Let's go and make it 10. And you can see that it worked once again. So there you go, guys. I'm ramping up the problems, making them a little bit more complicated. Don't worry if you don't get them all exactly right. This is just a process we're going to go through, and I'll progressively increase the complexities of the problems. And based off of your input in the comments, I will also go back and explain things further. So like always, please leave your questions and comments below. Otherwise, till next time.